More example. A car travels with uniform velocity of 30 meters per second for 5 seconds and then comes to rest in the next 10 seconds with the uniform deceleration. Roman 1. Draw a velocity time graph of the motion. Roman 2. Find the total distance traveled. Data given. Highest velocity, which is equal to 30 meters per second. Time 1, which is equal to 5 seconds. Finally, the car came to rest. Then its lowest velocity was 0 meter per second. And time 2, which is 10 seconds. Solution. Roman 1. Velocity time graph. Velocity in meters per second. Time in seconds. A car travels with uniform velocity of 30 meters per second in 5 seconds and then comes to rest in the next 10 seconds with a uniform deceleration. Time from this point up to this point is 5 seconds, and from this point up to this point is 10 seconds. Then 5 seconds plus 10 seconds is equal to 15. Roman 2. Total distance traveled. Total distance traveled is equal to the area under the graph. Area under the graph is equal to a half times the distance from this point up to this point, which is equal to 5 plus the distance from this point up to this point, which is 15 times the distance from this point up to this point, which is 30. 30 divided by 2 is equal to 15. 5 plus 15 is equal to 20. 1 times 20 times 15 is equal to 300. Therefore, total distance traveled is 300 meters. Exercise. Maria's car started from rest and traveled for 10 seconds at the velocity of 30 meters per second. She maintained a steady speed of 30 meters per second for 10 seconds, after which she applied the brakes and stopped after 5 seconds. Draw the velocity time graph and calculate A. The total distance traveled, B. The time taken for the whole journey, C. The maximum speed attained, D. What is represented by the area under the graph.